Hi, my name is Uzi. I'm a teacher at the System Engineering major and the Internet of Things at Kfar Galim High School. I have about 10 years of experience in teaching, and in my background, I'm a mechanical engineer. Um, so I'm actually also a mentor in this project that I will describe today. Um, the name of the greenhouse is kind of a technological social greenhouse. It's a totally voluntary pedagogical experiment project. Collaborating in this project were the Hebrew Reali School of Haifa, Regavim Special Education School, and Galim High School, located near Haifa. So the trigger for this project was in mid December 2020. We got a call for papers for the international conference on system engineering held on 16th of March and 17th of March 2021. And the idea was to show or to discuss in this conference the results of a project that we will develop with our students. So who's on this project? We have the Reali schools, the Reali students from the system engineering major from 10th grade, Regavim special education students, and Galim students from the systems engineering and the Internet of Things major. And the teachers involved are Gilad Bensky from the Reali, Maya Schwartz, Osnat Navon from Regavim, and myself from Galim High School. And also of course, we have a few plans waiting for the greenhouse to be constructed. Why thinking about the technology venture at school, and what are the needs? Why we started this project? First, we had the paradigm change that we understood that we have to change the paradigm and to develop a new approach for teaching, and it could be a great opportunity for this project. We understood that we have to adapt to hybrid teaching while students are mostly at home using Zoom. They do not have access to the labs and the resources at school like robots. Also, there were a few academic papers published during this time, and the position papers, and we understood that we cannot just read or write such papers, but also we have to implement and test the ideas at school. Also, we had the Education 4.0 in front of our eyes. The project-based learning and the ISTEAM and the lifelong learning. We had to incorporate all these ideas into one whole project. On the other side, we have also enabling technologies like Google Drive and all the mechanism of Google that provide us or enable us to write common papers and to share documents, and it is well accessed by all students at home, all teachers as well. We have also the Onshape. I will discuss it later, but let's call it the Google Drive for the computer-aided design. This environment provides us the mechanism or the ability to develop models, parts, assemblies, and drawings while students are at home, and they can collaborate freely using the Onshape Enterprise platform. And we have also, talking about platforms, we have several such several IoT platforms which we can use freely. Students can understand the Internet of Things concepts from home, and they can do a lot of progress without the teachers. So they can be just free to make any progress. The idea or the question is always if we have to wait for a top-down initiative from the Ministry of Education or schools or budgets, and this time we understood that we have to go the grassroots idea, and just to do it bottom up, no budget, everything is 100%. There is no obligation for any of the teachers and the students involved, and it is totally voluntary. So why the greenhouse anyway? First, it was an opportunity for us to experiment multidisciplinary ideas. There are few technology aspects in this greenhouse that are relevant to our major, like planning, design, 3D design, 3D printing, electronics, code development, and also the Internet of Things concepts. Everything in this project is relevant to our students. Also, the side of community and team working was considered. By community, I mean students from different schools can take part in this project. So we have two schools, the Reali Hebrew School and the Kfar Galim. From one side, and from the other side, special education school like Regavim can collaborate. Also, the team working that we can achieve a high level of team working, as I mentioned before, using the Google Drive and Onshape, and this is something also that we wanted to experiment. And why greenhouse? Also because it's a relevancy to school curriculum or to the major curriculum. Everything in this project is relevant, as I said, to the students, and also we can anticipate that we anticipate that the project or the student that worked on this project can take all these ideas to their matriculation exams, and everything that we do in this project is like pro for the 12th grade when they have to develop a full-time, full-scale project in their last year of study at school. So a bit about the pedagogy. As I said before, this is a project-based learning actually, and I think we have managed to achieve a great level of involvement of the students and engagement in production and manufacturing of this greenhouse. Not only to design it in 3D and maybe to print a few parts in 3D printers, but also to actually build and assemble the frames of the greenhouse, as we will see later. Also, the product has a great emotional value for both sides, both for the students designing and developing the greenhouse, because it's not like the usual projects that we have at school that they develop and okay, and then we have their projects to show off to visitors at school, but this specific greenhouse will be used in special education schools, so it have a kind of target. And also from the other side, the users in special education schools, also we see here an emotional value that they can appreciate. They can appreciate the students that built this greenhouse. The internal motivation here should be discussed, I think, more deeply, but we don't have the time. The idea is to have a project that it is not grades based, meaning that the students are not do not benefit directly from participating in this project. They do not get grades, or the project is totally on the during the free time, and they should understand, students involved in this project should understand that it is totally voluntary, and by this we measure the level of engagement of the students in this project, with having the grades aside, and see if technology can be of interest to our students. So a few words about Onshape and the technology. As I said before, it provides a full collaboration in documents. It's kind of a Google Drive for computer design. There is no hassle of installation for students at home. It is platform independent. There are no files, no need to save, no version management, and this is from the student side. From the teacher side, we can assist students online at any time. We can monitor students' progress during this project and see if they need any help, even if they are offline. And we can also evaluate students' progress and students' work, and see if we meet the project timelines. Okay, a few words about the technology, but from the microcontroller, the microbit side. This is a Scratch-like graphical code interface, as you can see. There are several built-in sensors in this inside this microcontroller, so the learning curve is very steep, meaning that students understand during the first lesson using the microbit. They understand the concepts of sensors, concept of programming, and also concepts of input-output. So we have also immediate controller response. It facilitates, as I said, the learning curve, and actually students spend more time on the concepts of the programming rather than the learning the grammar or how to code. They just code it, and it is very natural for them. And later to switch to Python or JavaScript languages, or any language that will decide, it's quite natural for the students. Also, a few words about the Internet of Things. The platform, the ThinkSpeak that we used or we chose as our platform is a very also there is no installation needed. It's a 10 minute. It takes 10 minutes to understand how to use it, and basically students understand very quickly the concepts of Internet of Things, including big data analytics. They understand the need for MATLAB or for a platform like MATLAB or MathCAD. So this is the Internet of Things side. So a few words about what is the size of or parameters of the greenhouse. It is 60 by 40 by 40 centimeters length, width, and height. It is meant to be used by at schools, special education schools. The infrastructure needed, I will show it in later. The idea also behind the development of this greenhouse is to teach students the parametric design. For example, if they design both the mechanical part and the electronic part of the greenhouse for 60 by 40 by 40 centimeters width greenhouse. What happens tomorrow when sizes will change and they will have to construct or to build a greenhouse which is 3, 4, or even 10 times bigger than this greenhouse that they are designing now. So, as I said, the external dimensions are 60 by 40 by 40, and we are using aluminum profiles as frame, and polycarbonate laser cut walls for the greenhouse. And from the other side, we have the infrastructure needed, 24 volt power supply. We have the need for water supply, a water drain, interfaces for the sensors themselves on top of the profiles of the greenhouse, and of course we have the need for an internet if we want this greenhouse to be Internet of Things part. The students defined these functionalities for the greenhouse. Of course, we didn't meet all these, but I will count a few. Irrigation, of course, of the plants, air humidity, and not only measurement and monitoring, but also controlling. Soil moisture measurement and controlling. We have a door opening and closing using a servo motor, and also a fence for air mixing and etc. So this is how the plants were waiting on the day of the conference. As you understand, it is very far from completion, and the greenhouse itself. This is how it was 2 hours before the conference, and you can see that in the background there is a pump for the water. In the front you can see the door mechanism. So currently we have we are less than a week after the conference, and we have almost everything built, but I don't have currently the pictures. So this is it. I hope it was of interest for you, and let's see if we can have a collaboration using this project. See you.